This video covers section 2.8 radicals. In mathematics, a radical expression defined as any expression that has radical. This is sign of radical, symbol of radical. This in here we call it root, and is any natural number greater than 1, like 2, 3, 4, 5, and so on. We call this k or anything under radical radicand. Usually when the root is 2, we don't write the root. Look at this one. We read it square root of a, but we write it as this form without root. If the root is an even number like 2, 4, 6, 8, if we have negative under radical, for example, I have a square root of negative 16. This is not anymore a real number. This is a complex number. In complex numbers, we call a square root of negative 1 as I. So if I square both sides, negative 1 equals to I square. When I write the square root of 16, that means which number, if you square this 16, you know is 4. 4 square is 16. But a square root of negative 16, because it's negative, that negative means I. Still a square root of 16 is 4. But negative under this radical, when root is an even, is not anymore real number, it's a complex number, so we have to put I here. To simplify a radical, if you have a number, first check if that number is a perfect square number. Perfect square numbers, they are 4, 9, 16, 25, 36. You know, 2 square is 4, 3 square is 9, 4 square is 16, 5 square 25, 6 square 36. So if your number on the radical is one of those numbers, a square root of those numbers is going to be easy to find. The square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. But 48 here is not a perfect square number. So we rewrite 48 as a multiplication of a perfect square number and another number. I know 48 is 16 times 3. Now, the square root of 16 is 4, but 3 cannot come out from radical, so it still is going to stay under radical. Let's do the second example. We said if we have a square root and negative under a square root, this means I. Means this one is a square root of 400 I. Now 400, I know 20 times 20 is 400. So 400 actually is 20 square. So I can write it 20 as 20 I. Next example, we have some alphabets, some variables on the radical. Everything exactly works the same. First, negative before radical, we keep that. Then I know 8, I can write it as 4, is the perfect square number, times 2. A is A. Now, b to the power of 3. I know b to the power of 3 is b square times b. B square is a square number, is perfect square, so I can take a square root of that number, take it out. Remember please that a square root of a square is a. Of course, if a is positive number, this one is going to be a real number. So for this example, 4 is a perfect square number. So can come out as 2. b squared, square root of b squared is going to be b. But 2a and b, they're going to still stay on their radical. In example 2, question asks to add, subtract, and simplify the answer. We can add or subtract terms with radical if exactly they have the same similar radical. Here 3 square root of 5 minus 6 square root of 5. Square root of 5 is that similar part. This is look like I say 3x minus 6x. So the answer is going to be negative 3 square root of 5. Look at the second example. 2 square root of 3 minus square root of 2 plus 5 square root of 2 minus 3 square root of 3. Here these two terms, because both have a square root of 3, they are similar terms. So 2 square root of 3 plus 3 square root of 3, answer is 5 square root of 3. Then these two terms, negative square root of 2 and 5 square root of 2, are similar as well. So I can add them, negative 1 square root of 2 and 5 square root of 2. Answer is 4 square root of 2. So this is the final answer. Look at this example. Look like radicals are not similar, but you can simplify a square root of 8a cubed. You know 8 is 4 times 2. A to the power of 3, you can write it as a squared times a to the power of 1. As we mentioned, square root of 4 is 2. Square root of a squared is a. So we have 2a times. On the radical, still we have 2a. Now if you substitute here, instead of 8a cubed, you can write 2a square root of 2a plus 3a square root of 2a. You see they are similar terms. 2a square root of 2a plus 3a square root of 2a. So if you add 2 and 3, you're going to have 5a square root of 2a. So to add or subtract radical expressions, always try to simplify each term, and then if they are similar, if you find terms are similar, add or subtract them. To simplify some expressions including radicals, when we are multiplying them, when we are dividing them, we need to know some rules. One rule, we can multiply two radicals by each other if they have exactly the same root. So a square root of or nth root of a times nth root of b, we can write it as one single radical, nth root of a times b. This rule exactly applies for division. Nth root of a fraction a over b, I can write it as fraction of, on the top, nth root of a, denominator, nth root of b. Of course, b cannot be 0, because if denominator is 0, then this fraction is undefined. This third root, we're going to use it more in next chapter when we are talking about exponents. But I would like to bring it here that nth root of a to the power of m means any radical that you have, you can write it as a to the power of m over n. We call this one radical form. We call this one exponential form. In future, we will use it a lot. Let's multiply and simplify the answer. The first one, we said that in multiplication, It's not necessarily that anything that you have on the radical must be the same. The only thing that is necessarily you must have the same root. So multiplication between these two terms, 3 square root of 2 times 4 square root of 2, numbers outside multiply by each other. So 3 times 4 is 12. Then square root of 2 times square root of 2. Square root of 2 times square root of 2 is square root of 4. Square root of 4, you know, is 2. So you can write it as 12 times 2. The final answer is 24. So please remember that square root of a times square root of a is a. Let's do the second example. We use distributivity property. So negative square root of 3 times 4 is negative 4 square root of 3. Negative times positive negative. 3 times 1, 3. Square root of 3 times square root of 6 is square root of 18. But still I'm not done here because I know square root of 18, I can write it as square root of 9 times 2. And I know square root of 9 is 3, so this is 3 square root of 2. So I can rewrite this one as negative 4 square root of 3 minus 3 times 3 square root of 2, because square root of 18, we got it as 3 square root of 2. So it's going to be negative 4 square root of 3 minus 3 times 3 is 9 square root of 2. I cannot simplify more than this because radicals are not similar and this is subtraction. So this is the final answer. The last part of this section talks about rationalized denominator. What does mean rationalized denominator? That means if you have a radical in denominator, you need to get rid of that radical. Here we have two examples. If we have a single radical in denominator, we will use this rule that square root of a times square root of a is square root of a square or a. So I know square root of 5 times square root of 5 is going to be 5. So I will multiply denominator by square root of 5. But please remember, in fractions, if you multiply denominator by any non-zero number or term, you must multiply top of fraction by the same number or term. So the answer is going to be 2 square root of 5, and I know square root of 5 times square root of 5 is 5. You see, we rationalize denominator, means there is no more radical in denominator. But example 2, we have two terms, 2 minus square root of 3. In this form, we have to use one of the rules that we learned in the past. A minus b times a plus b is a squared minus b squared. So here in denominator I have 2 minus square root of 3. 2 is a, square root of 3 is b. So if I multiply denominator by 2 plus square root of 3, this is a plus b, this is a minus b. So I can then write answer as 2 squared minus square root of 3 squared. Again, in this form, when denominator is addition or subtraction between two terms, we can use this rule. So I have 2 minus square root of 3. I will multiply denominator and top of fraction by 2 plus square root of 3. So the answer is going to be minus 1 times 2 plus square root of 3 and denominator is 2 minus square root of 3 times 2 plus square root of 3. In denominator, this is a minus b times a plus b. So it's going to be a square means 2 square minus b square means square root of 3 square. On the top of this fraction is negative 2 minus square root of 3. I know 2 square means 4 and square root of 3 square is 3. So in denominator 4 minus 3 is 1 and on the top I have negative 2 minus square root of 3. You see there is no more radical in denominator, means we rationalize denominator, we can write the final answer as this form 2.